This video is just to recap an exercise we will have done in class, which is another of the tests of human reasoning done by Wason. In this particular test, you're presented with an array of 4 cards. You're told that each card has a letter on one side and a number on the other. You're told that there's a rule that governs the combinations of letters and numbers, and the rule is this: if there's a vowel on one side, then there's an odd number on the other. Notice that this is very much of the if P then Q form. And the question is, which cards do you have to turn over in order to test the rule? Now, we can step through them. And we can first of all express that rule as a proposition of the form, if there's a vowel, then there's an odd number. And we've met our 4 forms of reasoning before that we went through. If P then Q, P therefore Q. That's correct reasoning, modus ponens. The first one would suggest that if there's a vowel, then there's an odd number. So if we see a vowel, we should find an odd number on the back, so we better check. You can step through the other 3 combinations there. We'll just look at them briefly. The first one, modus ponens, says if there's a vowel, then there's an odd number. So the A card has to be looked at. Right. Now, modus tollens says if P, then Q, not Q. If there's a vowel, then there's an odd number. There's not an odd number, therefore there shouldn't be a vowel. So if we see an even number, we will have to check that. So the card with 4 on it will have to be checked. However, the 2 logical fallacies also find representation here. If there's a vowel, then there's an odd number. There's an odd number, we don't actually care what's on the other side. There might be a vowel and there might not be a vowel, but that was not asserted. So this maps onto affirmation of the consequent. If there's a vowel, then there's an odd number. There's not a vowel, therefore we have absolutely nothing to say. So that's the last of the fallacies. Now, when we conduct this in class and when this has been done in experimental situations, people do very poorly on it. They always get lots and lots of these wrong, even though our 4 forms of logical reasoning, 2 valid, 2 invalid, are totally simple. And what I want to push against is the view that this shows that people are poor reasoners, because that's the way this experimental result could be interpreted. It turns out that people reason much better when things make sense to them and when they're meaningful. A's and 7s are not terrifically meaningful. Combinations of vowels and odd numbers are not terrifically meaningful. We can construct an exercise which has the same logical form, but is perhaps a little bit more meaningful. So supposing we've got 4 cards, and instead of vowels and odd numbers, each card has an age on one side and a drink on the other side. And you're walking into a pub and your job is to determine who you have to check. Our rule is, if you're under the age of 18, then you must have a soft drink in front of you. So which ones do we have to check in the pub? If someone's drinking a Coke, they're fine. Someone's drinking a beer, better check their age. If they're 16, we better check what they're doing. If they're 20-year-old, who cares? Nobody gets this wrong. Everyone gets this 100% right. It's logically exactly the same structure. So to leap from the experimental finding that people are poor reasoners, from the experimental finding on the task that Wason set up, to deduce that people are poor reasoners is itself a little bit problematic. And I think one should always be very cautious in interpreting such results.